In this video, we are going to find magnetic field of solenoid using Ampere's circuital law. In the last video, I discussed about Ampere's circuital law, that line integral of magnetic field is equal to mu naught times the current flowing through the closed loop. That was integration of B dot dl was equal to mu naught I. Now today, with the help of the same law, that is Ampere's circuital law, we are going to find magnetic field of solenoid. Now, what is solenoid? Solenoid is a cylindrical coil of wire, or you can say it is packed in form of helix. Like it has a structure like this. If you make number of turns of a wire like in this shape, so this shape is known as solenoid, right? And when you pass current through it, it behaves like a magnet. This is a basic diagram of solenoid. Now you have to find magnetic field of this solenoid, right? So for finding a magnetic field of this solenoid, you have to consider a Amperian loop here, right? So I will make one Amperian loop here like this. Let this be the Amperian loop for finding magnetic field, and let its direction be in this way, and you can also give name to it. Let it be A, B, C and D. And suppose length of this solenoid is small l. So let there be a solenoid of length L and n turns. Let the number of turns be n and I be the current flowing through it. Okay, and let there be one more term that would be represented by small n, and this small n would be called number of turns per unit length. Okay, let this small n be number of turns per unit length. That means capital N divided by length, that is small n. So the formula of n would be n by L. Now you have to find magnetic field of this solenoid. Now how you can find out? You will apply Ampere's circuital law on this Amperian loop. That is integration of B dot dl equals to, now this B dot dl line integral is in 4 parts over here, from B to C, C to D, D to A and A to B. So it would be integration from A to B of A to B, B dot dl plus integration of B to C, again B dot dl plus integration of C to D, B dot dl, and last is integration of D to A, B dot dl. See, the important point is you won't be using a closed loop over here because they are not closed ones. A to B, B to C, C to D, D to A are not closed loops. So for finding of whole closed loop, I am adding line integral of magnetic field of all these 4 points from A to B, B to C, C to D and D to A. Now you know how you open a dot product. B dot dl will be B dl cos theta, and similarly all these B dl will be opened in same manner. That is B dl is equal to B dl cos theta. Now what would be value of cos theta? Let us take for A to B. the directional magnetic field would be like this. That this is the directional magnetic field. So if A to B is your length element and magnetic field is like this, so the angle would be 90 degree, A to B, and this is your magnetic field, 90 degree. So angle here for A to B would be 90 degree, right? And cos 90 is 0. Okay, let us check for B to C. B to C is like this and magnetic field is like this. Same direction, angle would be 0. So cos 0 is 1, right? So this would be saved. It would be BDL cos 0, that is BDL only. So this will be left here. This BDL cos, you have to see angle again, CD. CD is going like this and magnetic field like this. Again, it makes an angle of 90 degree. Cos 90 again 0. So this part will also be 0. And last is D2A. See, the point D2A is outside the solenoid and magnetic field outside is 0. So this will become 0. So only one part will be left, that is from B to C. Now you can even also write this, that integration of A to B, B dot dl is equal to integration of C to D, B dot dl, that is equal to 0. Why? You can give reason, because theta is 90 degree. In both these cases, theta is 90 degree and cos 90 is 0. One more, you can write down that integration of d to a b dot dl is also 0. You can write down reason, because outside solenoid b outside solenoid. So if you substitute these values in this equation, you will get integration of b dot dl is equal to integration of b dl only of part B to C, b dot dl, and b dot dl would be b dl because cos 0 is 1. Okay, now if you solve it, what you get? You'll get b into integration of dl is L. So you get this. Let this be your first equation. Now if you apply Ampere's circuital law, what was Ampere's circuital law? That integration of b dot dl is equal to mu naught I. Right? Let this be your second equation. Now if you compare both these equation 1 and equation 2, what you get? You get b into L is equal to mu naught I. But if you have n turns, so for n turns, this is for 1 turn only. For n turns, it would be b into L is equal to mu naught capital N capital I. So value of b would be mu naught Ni. Value of b would be mu naught Ni divided by L. And also you can write it as mu naught small ni, because n by L is number of turns per unit length. So this would be formula of magnetic field of solenoid using Ampere's circuital law, that is mu naught Ni.